Welcome to The Explainer. Today, we're unpacking a really fascinating engineering log that details the inner workings of a massive, fully automated publishing network. And we are talking scale here, 474 different sites. But this isn't just a story about scale. It's really a detective story about what happens when an incredibly efficient content engine starts, quite literally, eating itself. Let me ask you something. How on earth does more than half of a massive publishing empire, and I mean literally 249 sites, just go completely dark, all while the engines powering them are supposedly running at absolute full speed? Sounds kind of impossible, right? But that is exactly the crisis this engineering team ran into. And honestly, figuring out why it happened reveals some absolutely incredible lessons about system architecture. So here is our game plan for today. We'll start in the engine room, check out the symptoms, make our diagnoses, walk through the three-part fix, and finally, look at why two systems are actually better than one. All right, part one, the engine room, the anatomy of the network. To really wrap our heads around this failure, we first need to understand the two entirely separate systems that sit at the heart of this whole operation. So picture the core architecture like this. On one side, we've got Stenbrick. Think of this as the news intelligence layer. It's pulling in hundreds of RSS and Atom feeds, scoring them, geotagging stories, and basically figuring out what's trending. This is the raw editorial supply. Then, on the flip side, there's Dojo Claw. This is the AI content engine. It grabs a story from Stenbrick, rewrites it to match the unique vibe of a specific destination site, and then fans it out across that massive catalog of 474 WordPress sites. They run on this deliberately decoupled setup. Basically, Stenbrick decides what's worth covering, and Dojo Claw decides where it goes and how it sounds. Moving right along to part two, the symptoms. A lopsided network. Everything seemed to be humming along perfectly fine until a startling 28-day engineering audit dropped a bit of a bombshell. It turns out the network was basically just publishing to itself. The data showed this massive, and I mean massive, concentration of output. Get this, 80% of all posts were landing on just 38 sites. Actually, it gets even crazier. The top 4 sites were each swallowing up over 200 articles a week. That's hammering a tiny, tiny fraction of the network with roughly 30 articles a day. But here is the flip side of that equation. While those top 4 sites were completely drowning in content, 249 sites, so 53% of the entire catalog, received absolutely zero posts during that entire 28-day window. Half the network was just left totally in the dark. Now, if you are running an SEO network, this is literally your worst-case scenario. You're spamming a handful of sites, which looks terrible to search engines, while those 249 idle sites are sitting there accruing absolutely zero value. Which brings us to part 3, the diagnosis. Diagnosing the disconnect. Now, it would be super easy to just point the finger at the site matching algorithm and call it a day, right? But the data showed this wasn't just one rogue bug. We're actually looking at two completely different problems here. Problem number 1 was this massive within-topic concentration. Remember those 4 runaway sites we just talked about? Well, turns out they were all in the tech or AI categories. The AI site matcher, which uses a large language model to pair an article to a relevant site, just kept coughing up the exact same broad text sites over and over for every single text story. And because the rotation logic was only designed to shuffle things within that matched topic pool, well, if a site didn't enter that pool initially, it never got a turn to publish, even if it was absolutely starved for content. And that leads us to the real underlying issue. There was a massive fundamental mismatch between supply and demand. Just look at the supply side. 53% of the content flowing out of Stenbrick was tech or AI related. But then look at the demand side. Only 13% of the sites were actually tech or AI sites. The vast majority of the catalog was heavily skewed toward lifestyle stuff: health, home, food, and fashion. So these lifestyle sites were quite literally starving because their kind of stories just weren't entering the pipeline. Tech content was piling up in one corner, and the rest of the network was abandoned. Okay, part 4, the 3-part fix, the treatment plan. The engineering team didn't just slap a patch on the code here. They rolled out a really elegant 3-pronged solution to fix both the placement logic and the content supply. First up, they tackled the placement side inside Dojo Claw by pulling 3 new levers. Lever 1, a per-site weekly cap. Once a site hits 25 posts in a week, boom, it's dropped from the candidate pool. Lever 2, a global LRU, or least recently used ordering system. This basically ranks sites by network-wide recency, so the sites that haven't published anything float straight to the top of the queue. And lever 3, a starvation floor. This just flat out guarantees that the most starved eligible site always gets picked. It's brilliant.
They traded a tiny bit of topical perfection to force that content deep into the long tail for way better coverage.
But here's the catch. You can't distribute content that doesn't exist. So step 2 was a Stenbrick supply rebalance. The team dug in, audited 105 existing feeds in those neglected lifestyle topics, and axed 6 that were totally broken. Then they actively brought in verified batches of fresh sources. We're talking high-volume hitters for home, health, and food, places like Homes and Gardens and Delish. In the end, the registry jumped from 245 to 271 active feeds, perfectly weighted to finally feed those starving lifestyle sites.
They did hit a little bit of a speed bump during this, though. It turns out some of the really big publisher feeds, like Vogue, GQ, and Bon Appetit, they throttle their RSS feeds. They only expose like 1 or 2 items at a time. It was a surprising little hurdle for sure, but not a deal breaker. The team kept them in for the time being, but flagged them to be replaced later, just to make sure they wouldn't bottleneck this shiny new supply chain.
And finally, part 3 of the fix, throughput. With the placement logic sorted and fresh supply pumping in, they just cranked the dials up. They expanded the fan-out width, meaning a single story now gets pushed to up to 7 sites instead of 5. Plus, they bumped up the quota depth, which scaled the daily article cap by 1.5 times. Pushing those dials up skyrocketed their daily ceiling from about 188 articles a day to roughly 280. That is a massive 49% jump in daily capacity. All right, bringing it home with part 5, why 2 systems work? The monolith question. Let's take a step back and look at the final results and really the whole architectural philosophy behind building it this way in the first place. When you put it all together, it's a picture of total recovery. The before and after is striking. That crazy concentration, 80% crammed onto 38 sites, it's now organically spread out thanks to those new caps and starvation floors. The number of dormant sites is actively shrinking as that new supply finally hits the tail end of the network. Feed sources are up, the daily ceiling is up 49%, and the fan-out width is wider. The whole system is finally breathing again. And I think this brings us to the absolutely crucial engineering takeaway here, decoupled systems. Supply and placement, they really are genuinely separate concerns. You've got Stenbrick handling the editorial judgment over this massive fire hose of feeds, right? And then Dojo Claw handles the fair organic distribution across a complex network of sites. You couldn't balance this whole thing without independent analysis of both the incoming content mix and the outgoing category demand. So I want to leave you with a thought to chew on. Imagine if this entire 474-site empire had been built as a single monolithic piece of software. Would the blurred lines between supply and distribution have created such a massive blind spot that the engineers never even found the true root cause? Decoupling these systems didn't just make the code run better, it made the actual problem visible, which made this elegant solution possible. It's definitely something to keep in mind the next time you are designing a system of your own. Thanks so much for joining me for this explainer, and keep building.